and I did all this stuff. And it's very helpful to do it that way. But my point in being is, you can listen to all the good advice from me now when I show you. But it doesn't mean anything necessarily when you take a test. Because if you don't practice that good advice, then what's going to happen? You're not going to remember. You just won't remember. You know? It's kind of like saying to people, I guess what? Oh, I don't know. I can think of some other thing. I won't, because we got to do some more examples. But, you know. Make sure you practice the good advice and not just take it. Because when the time comes, you won't remember it. So let's do another one of my favorite. How about number 28? Does that look like a good problem? Let's compare. So let's say 28. Notice this one. 2/3 times what? 2x minus 1 less than negative 14. This is number 28 on that worksheet. It's a good one. Okay. Compare what we did prior. What did we do before? You notice, didn't we use the distributive property here? I'm going to suggest to you, do something else here. You may say, what are you talking about? What do you guys think? What could you do here? Yes, I know you could use a distributive property. But here's another thing you could do. Here's another option. I'm going to multiply both sides by what? What's the reciprocal of 2/3? 3/2. Multiply 3/2 to the left. Multiply 3/2 to the what? To the right. And then what happens here? Let's say what? What's the product of two reciprocals? Don't they cancel, or isn't that the number 1 again? Good. So that's gone. What you now have is 2x what? Minus 1 less than, what's a negative times a positive? It's negative. What's that 14 being multiplied to? The 3 or the 2? Good. What's 14 times 3?
42.
Is it 42? So that's 42. Don't forget, you still have division of what? 2. You okay with that?
Yeah.
So we have 2x minus 1 is less than negative what number? 42 divided by 2 is? 21. Now, notice what just happened. By multiplying both sides by the reciprocal, this whole number times a fraction became a, well, it's not a whole number, it's an integer, it still became an integer. This is now a 2-step problem. Is that true? So notice you're in the 2-step situation. 2-step in the sense that a subtraction operation and a multiplication operation here have to be undone. We have to solve for x, get x by itself. What do you always do to do that? If you have those two operations, do you translate first or you divide first? Translate. Good. Move the 1 to the other side. So you have 2x on the left, less than negative 21 on the right. That negative 1 is now where?
Positive.
And it's on the what? On the right. So you now get what? 2x less than, what's negative 21 plus 1? Negative what?
Negative 22.
Negative 20. If you owe $21 and you only have $1, you can only offset $1. You still owe 20. What do you guys do now? Divide both sides by? Is that 2 positive or negative? I'm going to keep it blue. I'm not going to even put it red. I don't want to emphasize. Because am I going to switch my sign? No. If you had to, if you're the kind of student I was, I had to write down probably in words, do not switch. I'm going to say to you, do what? Not switch. Just so you can remind yourself. So you practice this good habit. And when you practice a good habit, you're more likely to do it. On a test, you're going to do it. So let's take a look. What does that give you?
Negative 10.
X is less than negative what? 10. Good. Here's my solution. What does set notation look like? Set of Rx such that x is less than negative 10. Here's a set. Let's look at the graph. 0, what else? Where's negative 10? To the left. Open circle shade everything where? To the left. What does the interval look like? Negative infinity up to? Is that both parentheses?
Yes.
Okay, good. Whew. You are what?
Done.
Done. So, what's your homework going to be aside from this worksheet? What do you guys have? You work on 2.6. When do you guys want to do that? You do it now. You do it today. You don't wait till the night before. Okay? All right. We'll see you guys later. Bye. So if it goes off, you let me know. It's supposed to be red. It'll do that. It'll do that, by the way. There's no way around it. It does it every 30 minutes. Okay, let's go over, some of you guys, we need to go over 4 last settings. This is the between setting. Okay, I'm going to call this between, and then we're going to look at some other examples. Okay? So we're going to finish this up today. I didn't talk about between. What I mean by between is that x, if you take a look at this notation, x is between what two numbers? A and what? B. This is what I call the between situation. X is between two numbers A and B. Okay, would you guys agree with that? All right, good. Now, we're going to do a couple of things. There is a graph associated with this. Let me draw a picture of the graph for you guys. Now, the graph looks slightly different. I have A and B. I just want to let you guys know that A is smaller than B. Okay, so A is going to be a number that's smaller than B. For example, if they wanted you to graph the following relationship, 3 less than or equal to x, which is less than or equal to, let's say, 7. Do you guys notice 3 and 7? What's the relationship between these two numbers? Well, they happen to be prime, that's true. But is it true that they're smaller? Is 3 smaller than 7? Okay, so the smaller number is going to be on the left, the larger is going to be on the what? The right. So what I want to say to you is make that point. When you go to graph, put on the left your what? Your A, and put maybe a B over here. So in this setting, 3 and 7, put 3 on the left and 7 on the right. I'm going to say put your circles here, your bubbles, like you put your bubbles over here in general. So let me give you the general format. Here's a specific example. X are the numbers between A and B need to be shaded. What numbers are between these two numbers? In other words, what portion of this line needs to be shaded? Whatever's in between. What's in the between? Right in the what? In the middle. You guys okay with that? So we shade the numbers that are right in the middle or right between, in between what two values? Here it's A, here it's B. In particular, numbers between 3 and 7, aren't there a lot of numbers between 3 and 7? Okay, like what numbers? 4, what else? 5, what else?
6.
How about 6.3? 6.893? 6.217? The point is, we're going to shade the numbers that are between what? 3 and 7. This shaded portion represents numbers that are between 3 and 7. Okay, you guys okay with this? Now, here's my question. Do we bubble in the numbers?
Yes.
How do you know? Do we bubble in the numbers?
No, they're not equal.
What do you guys think? You guys using your eyesight?
Yes.
You do bubble.
How do you know? Because it includes the possibility of equal. You see this here? How do you know you shade the bubbles? Yes, good. Here we go. So we're shading these bubbles here. This is what you have in general, so you guys know. We include A, we include B. This is what again? This is the graph. What does the interval notation look like? Stop and think about interval notation. Remember what interval notation would look like? We always start in what direction? To the left, all the way to the left. And we move in what direction? To the right. Is that true? So as we start from the left, are we walking on water or our feet wet? No. Starting where do we get our feet wet? At A. And notice we still get our feet wet all the way up to what? So we put comma up to B. Do we get our feet wet exactly at A and B? So put your what? Bracket. Good. So going back to describe this, in high school, this is high school notation for a graph. College notation, or notation you use for higher math classes like intermediate algebra, college algebra, pre-calculus, math analysis, whatever you want to call it, calculus. We actually put the brackets, the square brackets, again, here as well. So if you're looking back at the book and you see this as the graph, don't get nervous about it. They simply mean to do what? Include the A, include the what? B, because you have the equal here. Okay? Well, what does the interval notation look like here then? What would you guys say? 3, comma 7. Do you include the 3 and 7? Yes. So put a what? Put a bracket. And if you had the brackets here in back of the book, you should still be okay. So this is one scenario. And by the way, I want to point out to you, what you're looking at here, again, is another description. And you say to me, what are you talking about? Why do you want me to notice that this is actually a description? Well, why do we care that that's a description? Because when we write set notation, we say the set of all x, the set of all real numbers, the set of all real numbers x. This line means what again? Such that, what always comes next? The description goes here, ladies and gentlemen. What is the description? A less than or equal to x less than or equal to what? B. So we have the graph, the interval, and the what? Set. I'll write it out. Graph. Interval. Set notation. Okay, we just have to write the set notation over here. What's the set notation over here? It's the set of all x such that what? 3 less than or equal to x less than or equal to 7. So here's your set notation. Okay, you guys okay with this? So I'm going to call this your first setting of what we call the between situation. I call it between. And that's numbers between two other numbers. Here's a second one. Tell me if you guys can notice the difference. A less than x less than b. What do you guys think about that? Yeah, what's the difference between this second setting and the first setting? Does anybody notice?
They're not equal.
This is strictly less than. This is strictly less than. So if we had to graph this relationship, right, again, A is going to be smaller than B. So we have A, we have B. Open circle, shade everything in between because we're describing numbers. X represents real numbers between A and B. Is that shading numbers between A and B? Okay, good. What about interval notation? You're walking on the water again, starting from